Hello everyone, welcome back to our data structure lecture. Our new topic is quicksort and Radix sort. Here I am explaining quicksort algorithm and example and Radix sort algorithm and example.
Quicksort. The name quicksort comes from the fact that quicksort is capable of sorting a list of data elements significantly faster than any of the common sorting algorithms. In quicksort, arrange elements finding their position. Quicksort is based on the divide and conquer approach based on the idea of choosing one element as a pivot element and partition the array around it such that left side of pivot contains all the elements that are less than the pivot element and right side contains all elements greater than the pivot. Next is average case complexity is big O n log n and worst case complexity is big O n square. Working of quicksort. Here we discuss about basic idea of quicksort. This is example of quicksort. So here we first select pivot element. We can choose either first element is a pivot element or last element as a pivot element or median element as a pivot element or any element as a pivot element. So there are various techniques to choose pivot element. But here I am choosing first element as a pivot element. So here 5 is a pivot element. So first we find out appropriate place for this pivot element. So this quick sort is based on divide and conquer technique. It means arrays divide into sub array, means array is partitioning in two sub array, means left side partition and right side partition. So now first we find out appropriate place for this pivot. So we compare all these elements with this pivot element. If all these elements are less than this pivot element, then these elements are placed on the left side of this pivot element. If all elements are greater than this pivot element, then this all elements are placed in the right side of this pivot element. Now repeat this process from left side and right side partition. We select first pivot element from this partitioning array. So here 4 is now pivot element, then 3, 2 and 1 is less than 4. That's why we place these elements from left side of this pivot element. Now in this right partition 6 is the first element. That's why we select 6 is a pivot element. Now 8 and 7 is greater than this 6. That's why we place 8 and 7 from right side to the pivot element. Now repeat this procedure from this left partition. So first is now pivot element and 3 and 2 is greater than this pivot element. That's why we place this 3 and 2 from for right side of this pivot element. Now we repeat this process for this array, that is 2 and 3. Now 2 is pivot element and 3 is placed on right side of this pivot element. So repeat this process here also in right side partition, now 8 is pivot element and 7 is less than 8. That's why we place 7 in left side of this pivot element. So we repeat this process till we got only one element. So we find out the fixed places for this all pivot element and we got this sorted array. So now the sorted array is 1, 2, 3, 4, 5, 6, 7 and 8. Algorithm for quicksort. In step 1, consider the first element of the list as a pivot, that is element at first position in the list. Means we choose first element as a pivot element. Step 2. Define two variables I and j. Set I and j to first and last elements of the list respectively. Means I is point to the first index of the array and j point to the last index of the array. Step 3. Keep on incrementing I while a of I is less than equal to pivot. If element is less than equal to pivot, then we incrementing I. But element is means a of I is greater than pivot, then here we stop our I. Next is step 4, decrementing j while a of j is greater than pivot. So here if a of j is greater than pivot, then we decrementing j. But a of j means that element is less than pivot, then here we stop our j. So next in step 5, if I is less than j, then exchange a of I and a of j. So here when we stop our I and j, then we will check if I is less than or greater than j. So if I is less than j, then exchange a of I and a of j. But in step 7, if I is greater than j, then we exchange pivot with a of j. Okay. In this step 6, repeat steps 3, 4 and 5, means 3, 4 and 5 until I is greater than j.
Example of quick sort. Consider the following unsorted list of elements. We sort this element in ascending order. In algorithm, we used I and j pointer, but in example, we use left and right. If you can use I and j, then it's okay. Here, left point to the first position, means starting position of the array. So this starting position is 0, and right is point to the last position of this array. Now first check a of left is less than equal to a of pivot. We consider first element is pivot element, means 5 is a pivot element. So here we check a of left. A of left is also 5 and pivot is also 5. So a of left is less than equal to a of pivot, means 5 is less than equal to 5. This condition is true. Then left is incremented by 1. Now left is shifted to the in first position. Now repeat this process and we check this condition. A of left is less than equal to a of pivot. So here a of left is 3 and pivot is 5. So 3 is less than 5. So this condition is also true. Then left is incremented by 1. Okay, so here in case 3, left is point to the element 8. Now repeat this process. A left is less than equal to A of pivot. So here A of left is 8, less than equal to pivot is 5. So 8 less than equal to 5, this condition is false. So here our left pointer is stop. When left pointer is stop, then we decrement our right pointer. Okay, so here we check A of right is greater than A of pivot. So here A of right is 7. 7 is greater than 5. This condition is true. That's why we decrement right pointer. Now pointer shift to the second last position. Now repeat this process and compare right pointer and pivot pointer. So here we will check right is greater than pivot. So now right is 2 and pivot is 5. So 2 greater than 5, this condition is false. That's why here we stop our pointer. So left is stop in second position and right pointer is also stop in second last position. When these two pointers are stopped, then we will check left is less than right or greater than right. Okay. So here left is less than right. So whenever left is less than right, then we exchange left and right pointer. That's why we exchange 2 and 8. So now 2 and 8 we swap in next case. Okay, so we start again from left pointer. Okay, so our left pointer is incremented by 1. Why incremented by 1? Because we check a of left is less than equal to pivot. So here 2 is less than equal to 5. This condition is true. Then we will check next element, that is 1. 1 is less than equal to pivot. This is also true. So left is incremented by 1. Okay. Next, repeat this process and check a of left is less than equal to a of pivot. Now a of left is 4. 4 is less than 5. This condition is true. That's why left is incremented by 1. So now left is shifted to the next position. So here we check a of left is less than equal to a of pivot. Now a of left is 6. 6 is less than equal to 5. This condition is false. So here stop our left pointer. So now we will check with right pointer. So in right pointer we will check right condition is a of right is greater than a of pivot. So a of right is 8. So 8 is greater than pivot. This condition is true. That's why right is decremented by 1. So now right is point to the in fifth position. So next we will check again. Right is greater than pivot. So right is now 6. 6 is greater than 5. This condition is also true. That's why right is shifted to the decrement to the next position. Okay, so now right is point to the fourth location. So we here check again if right is greater than pivot. So but here right is 4. 4 is greater than 5. This condition is false. That's why here stop our right pointer. So now right pointer is in this fourth position and left pointer is in fifth position. Now if left pointer is greater than right pointer, then we will swap between right pointer with pivot element. So now right pointer element is present is 4. So now 4 and 5 is swap. So in next case here we find out exact position of 5. So here we will see in left side all element is greater than our pivot element, and in right side all element is less than our pivot element. That's why this is correct position for this pivot element. So in next step we will partitioning this array in two parts, that is left partition and right partition. So we will repeat this process in left partition and right partition. So this is left partition and this is right partition. So first we will choose pivot element. So pivot is the first position element. So here in first position element is present is 4. So 4 is now pivot element. So in right partition 6 is pivot element. So first we will check our condition, that is left is less than equal to pivot. So left is 4. 4 is less than equal to 4. This condition is true. That's why left is incremented by 1. Now again check this process and 3, 2, 1. These all elements are less than our 4. Now left is point to the here last position. Then we will decrement right pointer. So now right we will check with right pointer. So right is greater than pivot element. But here condition is false because in right present is 1. 1 is greater than 4. This condition is false. That's why we exchange means swap this two element, that is 1 and 4. So now 1 present in first position and now 4th is in fixed position. So we repeat this process in 1, 3 and 2. Now 1 is pivot element and we will check with this 2 element. Then see here in right side we will check left is less than our pivot element. But here first is left is less than equal to pivot. This condition is true. That's why left is incremented by 1. Now again we will check left is less than equal to pivot. But here left is 8. So 8 is less than equal to 6. This condition is false. That's why left is point to the this second position. Now we will see in right position. So in right position right is greater than pivot element. This condition is true. That's why right is decremented by 1. Then again we will check right is greater than pivot element. Then our right is shifted in decremented by 1. So now right is point to the pivot position, means first position. So here we cannot exchange our pivot and right because pivot and right element is same. So now 6 is in our fixed position, means correct position. Now we will check with 8 and 7, these two elements. So here we repeat this process, repeat this same recursively on both left and right sublist until all the numbers are sorted. Next is the final sorted list will be as follows: 1, 2, 3, 4, 5, 6, 7 and 8. Radix sort. Most of the sorting algorithms perform their sort by comparing elements. But in radix sort algorithm, a list of integer numbers will be sorted based on the digits of individual numbers. Sorting is performed from least significant digit to the most significant digit. Radix sort algorithm requires the number of passes which are equal to the number of digits present in the largest number among the list of numbers. For example, if the largest number is a 3-digit number, then that list is sorted with 3 passes. If we take number 200, then this number contains 3 digits. So, required passes is 3. Time complexity of Radix sort is big O n k, where n is the length of the array and k is the maximum number of digits. Example of Radix sort. So given list is 34814641385 3851 and 74. So we sort this list in ascending order using Radix sort. Here maximum number means largest number is 3851. This number contains 4 digits. That's why here passes required is 4. Now before starting pass 1, see here remaining all elements are less than 3851, means less than 4 digits. So we put zeros in left side from this remaining element. So start from first element, that is 348. This element contains 3 digits. That's why we put 10 on left side. Next is 14. This element contains 2 digits. That's why we put 2 zeros. Here also contain 3 digits. That's why we put 1 zeros on left side. Now next number is 74. This number contains 2 digits. That's why we put 2 zeros on left side. So start from past 1. So first number is 348. So least significant digit is 8, means last number is 8. That's why we put this number in 8th bucket. Next number is 0014. So least significant digit is 4. That's why we put this number in 4th bucket. Next is 0641. So here least significant digit is 1. So we put this number in first bucket. Next is 3851. So least significant digit is 1. That's why we place this number in first bucket. Next is 0074. So here least significant digit is 4. That's why we put this number in fourth bucket. Now we got new array, that is 0641, 3851, 0014, 0074, 0348. So in pass 2 we use this new array. So start from first element 0641, we choose second last least significant digit, that is 4. That's why we place 641 in fourth bucket. Next is 3851. Here second last least significant digit is 5. So we put this number in fifth bucket. Next is 0014. So least significant digit is 1. That's why we put this element in first bucket. Next is 0074. So here second last least significant digit is 7. That's why we put this number in seventh bucket. Next is 0348. So second last least significant digit is 4. That's why we place this number in fourth bucket. Now we got new array. So our new array is 0014, 0641, 0348, 3851 and 0074. So using this new array, we sort in pass 3. So using this new array, first number is 14, but here we use third last number, that is 0. So we put this number in 0th bucket. Next is 641. So here number is 6. So we put this number in sixth bucket. Next is 3, 4, 8. So here number is 3. So we put this number in third bucket. Next is 3851. So least significant digit is 8. So we put this number in 8th bucket. And next is 74. So here number is 0. That's why we put this number in 0 bucket. So arrange this number 1 4, then 7 4, then 3 4 8, then 6 4 1, and then 3 8 5 1. Now in pass 4, that all number that is less than 4 digit, this all number automatically placed in 0th bucket. So see here we move to the least significant digit to the most significant digit. So here most significant digit means starting number is 0. That's why we put this 1 4 in 0th bucket. Next is 7 4. Most significant digit is 0. That's why we put this number in 0th bucket. Next is 0 3 4 8. So here most significant digit is 0. That's why we put this number in 0th bucket. Next is 0641. In this number most significant digit is 0. That's why we put this number in 0th bucket. Next is 3851. So here most significant digit is 3. Now place this number in third bucket. So we got our sorted array, that is 14, 74, 348, 641 and 3851. So here we easily sort our array in ascending order using Radix sort. Algorithm for Radix sort. Step 1. Establish an array A. Means here A is array name with n elements. N is used for number of elements, that is A of n. Step 2. Let m be the maximum number of digits in any of the elements. Variable m is used for maximum number of digits. Step 3. Initialize Q from Q0 to Q9. Here, initialize 0 to 9 buckets means 10 buckets. Step 4. Repeat step 5 and 6 m times. Here, if maximum number of digits is 4, means largest element is 4 digits, then m is 4. Step 5. Place each element to one of the 10 queues according to the next significant digit, starting with the least significant digits. Means here we place numbers to bucket 0 to 9 with their least significant digit to the most significant digits. Step 6. Update array A using the element from Q0 to Q9. Step 7 is end. I hope all of you understand these two techniques, quick sort and Radix sort. Thank you.